All right, welcome to our pH lesson part 2. pH part 2. In this lesson, we're going to be working backwards. So in the previous lesson, you were given a concentration and asked to find the pH. For these problems, you're going to be given a pH or a pOH and be asked to find the concentration of the hydrogen ion or hydroxide. So let's start with a couple of formulas. First of all, when we need to work backwards with a logarithm, I want to remind you that pH is equal to the negative log of the hydrogen ion concentration. So if we need to work backwards here, and we know this value of pH, and we need to find this, we're going to use something called the anti-log, and that's what we do with logarithms. So it's essentially working backwards. So what that means is 10 to the negative pH is equal to the hydrogen ion concentration. So that's how we can work backwards and find the concentration from the pH. Same thing for pOH. We're going to have 10 to the negative pOH will be equal to the hydroxide concentration. So second formula that's important for us for this lesson. Okay, so this is old formula. We talked about that before. These are new and important for us moving forward. So let's look at an example or two. So first of all, okay, if you are given the pH of blood, true story, is 7.4. 7.4. What is the hydrogen ion concentration? Okay, so we're going to work backwards here. So we're going to use our formula 10 to the negative pH is equal to the H plus concentration. So in your calculator, if you're not familiar with these, you're actually going to type in, okay, 10. You're going to raise it to the power of negative, you have to type in the negative key, 7.4. That's going to give us the answer for H plus concentration. So 10 to the negative 7.4, typing that in my calculator, I get an answer of 3.98 times 10 to the negative 8 power. Okay. That's weird. What unit should that be in? Should we have a unit? Well, since it's concentration, remember I told you those brackets indicate concentration. Concentration in this case is in molarity, which is in units of moles per liter. So we can either put the big M or we can put moles per liter here as our unit. Right, so that is our H plus. Okay, for this problem. Now, what if I ask you to find the hydroxide concentration? A couple of things we could think about using the same problem. So first of all, if we know that the pH is 7.4, we can determine the pOH because we know that pOH plus pH, this is an old formula, is equal to 14. So if we plug in our known value of 7.4, 7.4 equals 14 plus pOH, basically what we end up with is, well, 14 minus 7.4 is going to give us the pOH. Okay, so type that in the calculator. Easy peasy. 14 minus 7.4. You're going to get an answer of 6.6. Yes, 6.6. So your pOH is equal to 6.6. Okay. So now, once again, to do the anti-log to find pOH, going to work backwards here. So the hydroxide concentration is going to be 10 to the negative, pOH, I forgot my P there, is equal to the hydroxide concentration. So 10 to the negative pOH is equal to the hydroxide concentration. So we're going to plug our numbers in. 10 to the negative 6.6 is equal to, okay, the hydroxide concentration, which is equal to 2.51 times 10 to the negative 7. Once again, I just typed that straight in the calculator, hit 10, raise it to the power of negative 6.6. I get a value of 2.51 times 10 to the negative 7. And that would be molarity, left that off there, for our concentration for hydroxide in this example. And that is it for today, guys. If you have any questions, let me know. Thanks.